Hi, everyone. Alex Frankel. I'm a program manager on the ARM deployments team, like Dan said. And I'm excited to hang out with you all for a while. And Stephanie and I have become kind of language nerds in the last year. So it's nice to be able to talk to folks like you who I know are also language nerds. And it's nice to see some familiar faces. I see Freak is here and Raul is here, and possibly some others that I missed who are part of the Bicep community. So it's nice to see you all.
Yeah, thanks, Alex. Hi, everyone. I'm Stephanie. I am also a program manager helping out on Bicep. Definitely not as well known in the Bicep community as Alex is, as he's been there through the start, through the creation of everything. But yeah, hopefully I can introduce you guys to Bicep and give a little better understanding to the people who are newer to this language. So before we start, I want to ask if anyone has had experience with ARM templates before. Maybe raise your hand or type in chat. Or if you haven't, you could type no experience at all. Okay, tiny bit. Cool. And who has used Bicep then? Nice. Sounds good. Let me share my screen really quickly. I will give a quick, yeah.
Sorry, can I actually ask, what about Azure as a whole? Is everyone mostly familiar with Azure, or are there some who are not using Azure today? Cool.
Everyone feel free to unmute yourself if you do want to talk, by the way.
Mm-hmm. Absolutely. Yeah, so if you have any questions, you can raise your hand or type in chat. And Alex will answer your questions and I will answer them if I see them, hopefully. Alex, feel free to interrupt me if I miss a question.
Cool.
All right, let's get started. I'm going to give presentation on just an overview of Bicep and then give a quick, simple demo of Bicep authoring a template. All right, so I want to mention that as we go, this PowerPoint assumes you have some knowledge of ARM templates, and it seems like a good amount of you guys do, and basic knowledge of Azure, but I will give some extra information on parts of Azure Resource Manager to give you some understanding if you don't already know it yet. I'm going to turn off my camera really quickly to make sure that this runs smoothly. I know sometimes with Teams, if you have your camera on and share your screen, bad things happen. Great. So let's get started with this slide. What is Bicep? Fundamentally, if you're using Bicep or ARM templates, it's to consume Azure resources. We have a lot of resources you can create, such as virtual machines, Kubernetes, app services, all under this cloud computing branch. When you use Azure Resource Manager, you're making a request to Azure to create you a new VM or a virtual network, and it comes through the Azure ARM API and gets routed to the various resource providers available on Azure. ARM templates are a way to create resources in Azure declaratively. You guys already know that. You'll author a template in JSON code, which I'll show an example later, and Azure will read that the resources you want to create with all of its different specifications and create it for you. It's extremely helpful if you want to recreate the same resources without having to go into the Azure portal and manually click through the different options multiple times. Now, what Bicep is, it's a higher level representation of ARM templates. ARM templates can be very verbose, and it takes a lot of effort to just learn the specific language to author a file. We created Bicep to be able to make this experience easier, and I'll go more in depth in the following slides as to why we put so much effort in improving the authoring experience. From Bicep, it transpiles into an ARM template code, which creates a deployment resource, and we'll go through validation to make sure your deployments are as successful as possible. Why Bicep? There are many ways to deploy resources in Azure. You can use Portal, PowerShell, CLI, Terraform, and all these other options available, which Dan says he will go into in another another time. So why are we creating another way to deploy resources? We see a lot of ARM template usage today with our users, and they are by far the most widely used tool to declaratively deploy resources to Azure. It's a large customer base using ARM templates, despite how difficult it can be to author them, because it's a very powerful and effective tool. So we wanted to take away a lot of that pain that comes with writing and developing ARM templates and turn it into a simpler authoring experience, hence Bicep. We want it to be better for current users and also make the ramp up a lot easier for new users as well. The benefits of Bicep. One of the biggest benefits is simpler syntax. It's, like I said, much easier to author, and as you can see, it's easier to read as well. Here, we're looking at Bicep code on the left and ARM template code on the right, creating the same exact resource in Azure Resource Manager. As you can see on the right-hand side, the ARM template has so much noise that it's falling off the page. It has a lot more brackets, more things in quotations and parentheses. That's just necessary to be declared in the JSON language. We had to have our ARM template embedded within JSON to make it work. And as you can see, it's hard to fully grasp what is in this template through all the noise unless you know a lot already. JSON is a data structure and not a programming language, which makes it a challenge to author. So we're redesigning the front end of the language to make it easier to work with the existing ARM template language. With Bicep, we're trying to move it past the JSON and give it its own file to live in. So day zero support. Some other benefits to using Azure versus other languages outside of Azure. And one of the biggest benefits to using an Azure native language is day zero support. This is a snapshot of all the services, not all of them, a lot of the services available in Azure, and this list is growing every single day. With other tooling, there's an onboarding process in which they have to create a client to work with new services, resource providers, all of the things that is available in Azure. And we don't have to enable anything first for it to be available to be consumed and deployed with Bicep and ARM templates. So if you're looking to be on the bleeding edge or you're hoping to immediately use a new version of something, this is the shortest possible path to use new features. With Azure growing and improving so quickly and features and services being added all the time, Bicep and ARM templates can keep up with this with day zero coverage. Modularity. This is one of the things that was really challenging to do with ARM templates. I don't know if you guys had trouble with them, but a lot of people have had trouble with modularity. So there were linked ARM templates to be able to sort of rough patch files together, but we wanted to be able to fundamentally fix that. So what we've done with Bicep is create a kind of first-class modularity and first-class code reuse, which is the standard for most programming languages to be able to break down code so other people can use and reuse files. And we wanted to make sure that Bicep supported this as well. Another really big strength with ARM templates that our team has put a lot of work into is toolability. So what that means is that we do as much as possible to validate as you're authoring within VS Code. When I do my demo, I'll show you some of the really great IntelliSense and validation. We expanded the capabilities from ARM templates into Bicep, like syntax highlighting and better IntelliSense to make that experience better. We found that tooling is one of the most basic and fundamental things to the design of a language and compiler. It has to be designed to work and fail well for the user. So everything we're building into Bicep is with tooling in mind to have it work with the language server. Because of this, Bicep has rich IntelliSense and validation today, which we're working on continuously making it better and more accurate with each version release. Our tooling is built much more like a programming language and will feel similar to authoring C# files. We've gotten a lot of insight from the people who created these programming languages within Microsoft. No state management. If you're familiar with Terraform or have worked with people using Terraform, you know that they're reliant on state management as a snapshot of what would have been seen in Azure. In ARM templates and Bicep, we're able to leverage Azure as the state itself. So you can perform a deployment on any device and always pull the state to run a tool with it immediately. Goals. I've been touching on these goals for the past few slides, but I want to reiterate the goals as well as the non-goals decided when Bicep was first being developed. We want to reduce the current pain of authoring ARM templates, which we've been able to achieve so far. We wanted to lower the barrier to entry as much as possible, and we want to be a transparent abstraction, which day zero support achieves. We also wanted modularity, which I referred to already. We're making it better every day. For the non-goals, these are just as important as the goals, if not more. So we have no intention on having Bicep be the only language out there for cloud users or Azure users. Whatever way you are interacting with Azure, whether it be Portal or Terraform, or helping other people interact with Azure, as long as you are happy and successful in what you're trying to achieve, that's what we want for you. ARM templates are able to help users out in achieving their goals in Azure, and Bicep is just a more improved way to do so. We're also not trying to be a general purpose language. There may still be data processing tasks outside of the template you'll need to do with your own scripting and pipeline, but you can pass those outputs into Bicep or pass outputs from Bicep into those tasks as well. So basically, there's no goal for Bicep to fill all of these gaps and steps that might be taken and create a general purpose language. So where we are, version 0.1 and 0.2 was about a year ago. That was our experimental version, just trying to see if it works, see if it's better, and get people's thoughts. March was our 0.3 release. This was the production ready version. This was a really big deal. This had ARM template parity. So anything that you did with ARM templates can be done in Bicep. And where we are now, this was recent, our version 0.4. This was the first post-production release. It has an emphasis on quality and stability and speeding up the inner loop. We have fixed and improved a lot of bugs, and we're still doing that every single version. We're making small changes to make that experience with Bicep better in our future releases, and there are a lot of cool things that will be coming up. All right, so I'll go into the demo, but first of all, does anyone have any questions? All right, let me change my screen. Okay, can you all see this?
Yes, we can.
Cool, thank you. All right, so I'm in VS Code right now. I don't know how many people use this to author their templates, but this is where our main tooling is. So you just have to go into extensions, search up Bicep, as I did before, and our most recent release was 0.4.613. You'll get updates automatically within VS Code. They'll be able to manage updating that for you. So basically what this extension does, it understands the language you type out. Like for the C# extension, if you're using that, it reads your Bicep language and knows to run our language service, which provides all the great tooling we have for you. So it's a .bicep file extension. So VS Code will automatically read that at the bottom right here once you create that file itself. Yeah, so we can get started authoring a resource here. If you're familiar with Terraform or ARM templates, both will start out with a resource. So we'll start out with a resource keyword, and then you give it what we call a symbolic name, which is basically just a variable reference. You can put whatever you want here. I want to create an app plan. So I can just write app plan. You can put anything here. And IntelliSense then pops up to ask me what type of resource I want to create. Each option here tells us exactly what resource type we want with the API version listed as well. I can type out server farm, which is what I want here to create an app service. This is what the app service plan is called at an API level. So when authoring a Bicep file or on template, you'll need to know the specific names of each resource you're hoping to deploy, which can be a bit of a learning step, as you guys know, but we're planning on making this step a little simpler to understand by aliasing them from these longer strings. For now, these are important to understand each type and what they deploy. So if you're using Terraform or PowerShell or anything else, it might say app service plan in that context, but usually it will show up with the name server farm. So learning Azure Resource Manager at its lowest level would be extremely valuable when authoring both ARM templates and Bicep templates, since it gives you the context of what's happening underneath the file itself. So I'll pick this server farm and choose the most recent API version, and I'll write equals open bracket. Right away, I'm told that this resource is missing information from this red squiggly, and I'll need to include the name and location properties. So I'll give this website a name. I'll call it Stephanie site. And I'll add a location by writing resource group location, which is my resource group's location. If you're not familiar with resource groups, in any Azure subscription, you can have a number of resource groups. Each resource group has a location which corresponds with one of the data centers in Azure. So I'm setting the location to be the same location where the resource group is located. After this, I need to define a few more properties. So I typed control space here to get this drop down of other available properties. This menu is generated from what the resource provider gives us. And in this case, it's Microsoft.web. They define the APIs in Swagger, and we consume that to generate this information off of what they defined. So this pretty much shows that we're a thin abstraction. We're not creating this list of properties. This is just what we get from the resource provider directly. So I want to write out the kind. We want to create a Linux app service plan. And for the SKU, this has to be an object. And I just want a name, which I'll choose B1. This, like before, is knowledge you'll need to know about ARM before writing the template to know the different values you can include here. But for me, I'll choose B1, which is one of the most basic tiers. Generally, most resources have different SKUs that generate different levels of performance. And sometimes information that should be provided in the API definition isn't. So in those cases, we will work with the teams to make it more apparent. But if not, you'll have to look deeper into documentation onto what values you can include. We'll also add properties. And here we'll have reserved true so that the app plan can run on Linux. So I want to create a parameter because I don't want a static resource name. So param is the keyword we use, and I want to use the symbolic name prefix. It will be a string type, and I will edit the resource name here to use string interpolation. So this will pop up, name prefix. We like that IntelliSense. And I want to create one more parameter, the SKU. So the SKU will be a string, and I want to give it the default value of B1. In this case, I can replace the hard-coded SKU with the parameterized SKU. And simple as that. The last thing we're authoring is an output. When I consume this Bicep file, I'm going to want to get some information from it to be able to work with the app service plan in another Bicep file or in a script or a pipeline. This output allows others to work with this file and consume it as well. So I'll create the output called plan ID, which is also a string, and reference the app plan here. This pops up automatically, and I want to choose the ID so I can output this particular ID. Resource IDs are very important to using and understanding Azure, and we've been able to really successfully incorporate IntelliSense into Bicep. So with this, we have high confidence the file will emit the right resource ID through seeing all the different properties available with this resource here. In this case, we want to output the ID, and it just shows up. Now, this is what is considered a raw resource declaration. At the lowest level, this is what the API expects when creating a resource. From this step, I could also consume this as a module, and using a module, you won't have to rewrite the code to deploy it again and can just reference it and populate the parameters as necessary for each deployment. We're also currently working on building a module registry for public and private use at the end of this month. If you guys are following that, we're pretty excited, so look out for that. So now we're going to switch over to our main Bicep file, which is what we're going to use to consume the module we just wrote. The first thing you want to do is set the target scope. This could be any of the 4 scopes listed here and in Azure. You can deploy a file to a single resource group, a whole subscription, a management group, which is a collection of subscriptions or other management groups, or to an entire tenant. Our most common use cases, though, is a resource group or subscription. So we'll set it to a subscription. And the next thing we're going to do is create a resource group, because most resources that you create in Azure live in a resource group. So we'll create another raw resource, call it RG for resource group. And I'm going to search up resource groups and pick the most recent API version listed again. And as you can see here, it just needs a name and location. So I'll give it the name Stephanie Y resource group and location. I don't want to hard code this location either. So I'll just have this point to the deployment location. So deployment is another resource that gets created as part of the code. So we can just pull that location from the resource. Now I want to refer back to the app service plan we just created. So we'll use the keyword module here and call it app plan deploy for our own reference. And I'll get some IntelliSense on what I can consume as a module based on type. So we'll choose the app plan.bicep file we just created and equals open bracket. Here are the properties we can set. We can choose depends on, name it, add more parameters, set the scope, which is where you're going to deploy the module. And so the module is just a bicep file and can be deployed to any scope in Azure, and we want this deployed at a resource group. Coincidentally, we just created a resource group. So we can reference it as RG. And so it knows to deploy this app plan to this resource group. I also need to give it a name. So I'll call it app plan deploy. And I want to set some parameters. So here we have two potential parameters we configured in applan.bicep, and only the name prefix is required, as you can see. If I wanted to overwrite the SKU and give it a better SKU, I could also do that here, but that's unnecessary for me. So I'll just set the name prefix to Steph. And this is all I need to deploy the app service. Now, this block of code is integral to modularize the code, an important concept to learn when you want to consume modules for future use. We've tried to make it easy and straightforward to simplify modularization and help you manage them more efficiently. And the last thing we're going to do is instantiate the website itself. I have another bicep file here, which creates a website. I don't want to go too in depth with this since it's a pretty standard resource definition for a website, and there are a bunch of parameters that have been set up for me. So it's going to output some information when I deploy. Specifically, this website deploys Docker images as its source of application code. So we're going to reference an image from Docker Hub into our main bicep code. So back to main, I need to author another module, which I'll call deploy site. And I'll reference the site we just looked at. So this also needs a scope. And I'll scope it to the same resource group. It needs a name, which I'll call deploy Stephanie site. It needs parameters as well. And IntelliSense will show us what is required here. So it looks like 4 things are required based off of the site file that was created for us. And I'm going to start with app plan ID. So referring to the raw resource above, we just created this app plan, and the website will have to sit on top of this app service plan. So we have to tie them together. In order to do this, we'll have to grab the output from the app plan module. So using IntelliSense, we can type app plan deploy, grab this output, and then plan ID. Simple as that. Then I'll also need a Docker image, which I'll write as nginx demos hello, which is just an image, and the Docker image tag as latest. Need one more, the name prefix. Again, I'll just make it Steph, pretty simple. I'll also want to set an output, which is the site URL, make it a string, and this will be site or deploy site dot outputs dot site URL. So pretty simple. So when this template runs, it will output the URL and I can go directly to the site itself. All right, so now we have to deploy this. We can either use Azure CLI or Azure PowerShell, whatever you're more used to, but I'll use Azure CLI. I'll type AZ deployment sub create. Depending on what you're deploying, it can be AZ deployment tenant or resource group or MG, just whatever scope I targeted in Azure here. So we'll point to the file main.bicep, give it a location. I'll give it East US and -C. So -C will run our what if, and that will predict our deployment for us. So when we run what if, it's going to show us what we're going to do. If there are any errors found in my code, they're going to catch it because we want to do some further validation. And if it's good, we can choose to deploy it. So let me give it a little bit. Just takes a minute or so. Cool. So it shows us the different resource group or the resources that we want to create and all of the different specifications that we made. So you can type no or yes. So I'll type yes, and this will take a couple minutes. So in the meantime, does anyone have any questions, anything in chat that Alex couldn't answer?
We've mostly been able to keep up with the chat, but if there are any additional questions.
I'm just wondering whether for the benefit of the recording, it's worth just mentioning the questions in the chat anyway, even though they've already been answered.
Oh, sure.
Okay.
Yeah, Alex, do you want to read them out and answer them? I know
Yeah.
you answered a bunch of them already.
So one question was about the ability to migrate from ARM templates to Bicep. And for that, we have what we call a decompiler. So you can run Bicep decompile, or actually it may not be in the build that Stephanie's using, but in the next release of Bicep, you'll be able to just right click on the file in VS Code and do, I think both build and decompile, but it may just be build for now. Either way, there's a way to do it. And there's a doc that I put in the chat that walks through it all. We also have a migration guide that will kind of walk you through verifying and transitioning from ARM templates to Bicep safely. So especially, a lot of these ARM templates were like exported ARM templates or things like that might have superfluous information or may not be exactly in sync with what's in Azure. So the migration guide actually does a really good job of walking through a set of very safe steps for getting from A to B and winding up with like good idiomatic Bicep code. Can we run Bicep as part of a DevOps release pipeline was the question. And we do have docs on using Bicep in both DevOps pipelines and GitHub actions. What I tend to do is just run it through Azure CLI, which has the Bicep commands built in. That way I kind of just know it's there, but there are some special case tasks for deploying ARM templates that we're starting to add Bicep support to as well. And the doc should include exactly what is where. There was a question about SKUs and auto completing them. I don't know, Stephanie, if you want to take that one and talk about what the RP teams are doing in terms of publishing swaggers and how we then consume them.
Yeah, so unfortunately, this one doesn't have autocomplete. Some other RPs will have that available for you, but right now we're trying to work on talking to the different RPs and have them update their schemas and swaggers to be able to allow for that autocomplete. But it's a bit of effort, kind of trying to pull teeth a little bit, reaching out to everyone and telling them that this is important to update. And we'll try to get all of those available for all of the different RPs available. And
part of the secret master plan of Bicep is to kind of steal back some mind share so that the RP teams know to care about their Bicep experience for things just like this and making sure their Swagger API specs are accurate and so on, which has a side benefit of improving lots of tooling in Azure that depends on those Swagger specifications being right. So we're already seeing the benefits of kind of driving some of that, but it is, like Stephanie said, definitely a cat herding kind of process, but we are chipping away at it. Let's see. Does Bicep support all ARM template schemas? The answer to that is yes. So Stephanie showed the target scope keyword, line 1 in the code that we're looking at. That's what effectively maps to the schema property in the emitted JSON. So you target your template to different scopes in Azure. That translates to a specific schema where we say these resource types are allowed at this scope, and Bicep does all that validation for you. So if Stephanie tried to create a website directly in this main.bicep file, it would throw an error saying you can't create a website at the subscription scope. It has to be at the resource group scope. And that's why in the module declarations, there's that scope property. That's what's kind of managing all of those mappings. There are a bunch more questions, which is awesome. I'll get on camera as well. I forgot to turn that back on. Functions, any examples? So always the question about user-defined functions. Cool. So user-defined functions are technically the only thing from ARM templates that we don't support in Bicep. The reason is that user-defined functions in ARM templates kind of have some rough limitations that make them not very useful. Particularly, they can't be shared across files. So we want to kind of revisit the design of functions. You can kind of abuse it with modules. It gets a little tricky, but I've seen it done before. But we do want to have proper user-defined function support and have them be shareable, not just within your code base, but Stephanie touched on the registry capability. You can imagine user-defined functions and libraries of user-defined functions being published to the registry and shared. So there's a lot of like potential there. But we just haven't had the opportunity to work on it just yet. Stephanie, have you taken a look through any of these in particular?
Yes. There was one question that's been asked a couple of times in our past. Would it be sensible to make lots of Bicep templates and throw away our ARM templates while Bicep is still version 0. something?
Yeah, so Bicep is supported in production. It's literally supported by the same support team that supports ARM templates. So they're total experts, and they've trained up on Bicep, so they know what they're doing there too. So there's no concern from our perspective of supporting it. The reason we have a few things that we want to get done before we declare 1.0 and kind of finalize our breaking change policy, and we can talk about that in a bit. But that's the reason that we're not 1.0 yet, not because we're not supported in production. Dan, thank you for answering the questions about loops and if statements. You guys know better than I do, or maybe Stephanie, you know this well. I don't know where the line is of Turing complete and not, but we have some conditional expressions and loops, so we're probably pretty close. So you can do some pretty dynamic things with Bicep. Just scrolling through here. Is there any support for parsing Bicep files programmatically? For example, pass a Bicep file and get a list of the required parameters. We don't really support this today, but we do want to enable it in the future. So the Bicep compiler is all written in .NET. It's really just a matter of us like cleaning up all of our APIs and publishing it as a NuGet. So it's definitely something that we can enable and want to enable. We just haven't had the opportunity just yet.
There's one, is day 0 support for preview features too, or just GA?
Do you want to answer that one, Stephanie?
I'm pretty sure it's also for preview features too. Anything that gets released into Azure, you can use it and consume it.
Yeah, exactly. So the nice part about Bicep being what we sometimes call a transparent abstraction that Stephanie was talking about is there's nothing that needs to happen to enable Bicep support. There's the API definition that gives us type information and helps us validate more richly. But even if we don't have that, you can still deploy any resource type in Azure or any new API version as long as it's available in production. And if it's a private preview, your subscription may need to be onboarded, but that would be the only thing that needs to happen. Using modules for different resources seems to simplify the overall template, but will each group end up building their variation? How about a library? Stephanie, do you want to touch on kind of our registry plans?
Mm-hmm. Yeah, so we're trying to build up a module registry. So this will be for public and private registry. So you could do it within your organization, or you can also publish them to a public registry. So other people can use them, other people can change them, and that will be available at the end of this month is what we're hoping for. Alex, what is that plan?
Yeah, I think we're going to ship a release. At this point, it's probably going to be just before the 0.5 release, which has private registry support. So the way it's actually going to work is you'll need an ACR instance in Azure, an Azure Container Registry. And we use something called the OCI artifact spec, or we implement it, or ACR implements it, which essentially allows you to shove anything into a container registry and have it have like container semantics of pushing and pulling and that sort of stuff. It makes it really easy for us to kind of distribute and for you to distribute content And we abstract a lot of the details of that. But anyway, with this next release, you'll be able to put modules in a registry and share them. You can even make the ACR publicly available. And then we'll also have eventually a public registry where you can submit PRs to, and that Microsoft will publish like known good modules for common use cases and common resource types. That'll probably be a little bit later, probably about a month after that private registry release.
Yeah, I'm trying to link our GitHub issue, but we have a lot of them on the registry, so I don't know which one is the best.
Yeah, I can try to pull up the one I typically send people.
Okay.
A little disjointed.
Yeah, if any of you guys want to look for more information on documentation, we don't have anything on Microsoft Docs yet. That will come out as soon as the registry is released. But for now, we have a lot of things on GitHub following this. Okay, cool. This was the one I was looking at, but this was one of our very first issues. So it was.
Yeah, I think that one has enough links to the other relevant issues that if you're really curious, and if you're really adventurous, you can go and download the nightly build of Bicep and start playing with it. And Stephanie, if you have the link to the most recent community call handy, that kind of walks, Marcin, the engineer who built the module registry, walks through the end-to-end of what that's going to be like if you want to look at that in a bit more detail and try it out.
Let me drop that link.
Can I ask a quick question?
Yeah.
So I know at the moment, I know in the future you're planning to add support to pass resources as parameters into modules, but that's not there yet. In the meantime, what's the recommended pattern for example, in one deployment, if you've got a module creating a resource which is used by another module, what's the recommended pattern to actually reference one from the other? Do you have to use, because I've been using the existing and I don't know whether that's right.
That would be like the idiomatic way to do it, because that gives us the most type information on the resource that you're working with, and that we can do IntelliSense and validation and all that sort of stuff at that point. So until that feature is done, that's how I do it.
So how does if you're doing existing and the resource you're referencing is also being created in the same deployment, does that sort out the waiting for it to be fully deployed before it does the next bit properly across modules?
Yeah, it gets a little tricky. Sometimes there may not be enough context to automatically determine the dependencies. So for those that don't know, especially if you've used ARM templates, you almost never have to worry about depends on anymore. That symbolic resource name where you can pull properties from. So Stephanie showed getting the ID of the server farm. The way that you retrieve that, we're able to automatically determine all the dependencies. There are cases like what Dan is describing where we may not have enough of that information, and you may need to set the depends on manually to the module that created that resource. But that's the exception to the rule for the most part. And then once we have that feature implemented, you won't need to do that anymore.
Oh, so you can do depends onto a module.
Mm-hmm, mm-hmm.
Oh, I didn't know that. Okay.
And you actually, it's a little confusing. So there's this concept that Dan's talking about of establishing a reference to an existing resource. So if you're not creating it, ACR is a good example where you're probably not creating a new ACR, you're probably referencing an existing ACR, and maybe you want to get credentials to it. So you can actually set up a reference to that resource where we can still do IntelliSense and validation because we have all the type information. And when you do that, you're not creating the resource. So you can't set a depends on an existing resource because it kind of doesn't make sense. You have to make the dependency on the thing that's creating the resource, if that makes sense. Is there a Bicep visualizer? There is. So in the top right corner, when you're on a Bicep file, there's a little graph looking icon, and that will visualize everything. And It's kind of cool because it's basically what the language server sees. So we're basically just exposing that to you. We know all those all that dependency information and what's talking to what and where your module references are. So we're able with the visualizer just to show that all to you. And we have all the pretty icons there now. So it looks pretty good. It's pretty nice. Oh, cool. Yeah, there it is.
Yeah, this
And
one's
that
pretty
will-
cool. Usually there's a lot more here.
Yeah, this is a simple one. And it'll update in real time. So as you're authoring the code, the visualizer will continually update. Any other questions?
There's a question on feature flags or environment toggles like in Terraform. Do we have anything like that?
I'm not familiar enough with what that is in Terraform to say with high confidence what that maps to in Bicep. I don't know if Terraform has a way of exposing new features for a resource type separate from how we expose things. So I don't want to misspeak. I don't know, but I'm happy to follow up offline on that one.
Also, we have monthly community calls. If you want to sign up here, I'll send out the invites, and also you can sign up for our newsletter. That will be sent out every time something big happens. So hopefully soon in our 0.5 release, you'll see something in your mailbox if you want to.
Yeah, with the feature, I was just typing in the chat, but I may as well say it. But with the feature toggle, I tend to just use like parameters, like Boolean parameters, and because in the resource, I don't know whether it's easy to show, Stephanie, but I think for the for loop syntax in the if statement, it just looks so nice and clean. You can like next to the resource definition before the squiggly bracket, you just put, I think is it just if, and then the Boolean, just like you would in .NET, and then that whole resource just doesn't get deployed if the condition isn't met. So I kind of use that for feature toggles, and that works really well. And quite often I can pass the parameter being passed in from Azure DevOps pipeline, so you can have different environments setting different flags.
Yeah, okay, got it. That makes sense. And you can set conditions and you can iterate over modules as well. So you can have, you can have your infrastructure broken into kind of distinct sections that have a module boundary, and then choose to conditionally deploy them. Or like with the website that Stephanie has a module for, that's a good candidate to iterate through if you want dev, test, and prod websites. You can feed in some iterator or some list, and then we can create n modules depending on what's in there. Would it be possible to explain where it makes sense to use Bicep instead of other tools like Terraform, Farmer, Pulumi, etc.? Great question. Dan's going to end up answering that with his friends at the DDD conference, which I'm looking forward to. I think here's how I think about them. We think that the ARM template is a very good deployment binary or deployment artifact, because what happens is you send us the whole ARM template and we can do pretty deep validation. We can even talk to the resource providers and say, hey, Alex is about to create a VM and it has these properties. Is this VM name available? Does this image actually exist? So on and so forth. That's harder to do in some of the languages like Terraform and Pulumi, because they are brokering all the API calls for you. They are the engine that's talking to Azure repeatedly to manage all of that for you. So they would have to come up with an equivalent capability to do that deep validation, which is not a straightforward thing to do. So that means that Bicep and ARM templates, if you want to author them directly, and Farmer all share that benefit, because Farmer like Bicep, will eventually become an ARM template at some point before it's sent to Azure and deployed. So if you're in the .NET ecosystem and you want to write .NET, Farmer is a really cool way of doing it. And we are in talks with Isaac and the Farmer team to get more resource coverage. We'd love to see them consume some of the NuGets that we make available in Bicep to make all the resource types available. We'd love to be able to see that in Farmer as well, to have basically day zero support. Pulumi and Terraform are great tools, especially if you need to collapse on workflow. So if you are a consultancy and you're going to work with many different customers that use Azure and AWS and GCP, Terraform and Pulumi are interesting and helpful because you'll have a similar workflow for deploying to all those environments or all those clouds. You still need to know pretty intimately how those clouds work, because a VM on Azure does not work the same as a VM on AWS, and those are probably that's the most common resource type. When you get into things like websites and AKS and these things that abstract more things away, that gets more challenging to work across clouds or between these different cloud services. But you do definitely get a benefit of collapsing on workflow. So like most of these technology decisions, they're not straightforward. There's a lot of different factors that go in, and the answer is genuinely different depending on who you're working with or how you're working with Azure or with other clouds. Hopefully that's helpful. Cool. Felix asked if there are array types, and Dan answered. There are array types. There's an object type. There's a lot more to extract out of the type system. So we're pretty excited to keep pushing on that. So today, if you have a module, you can have an array type, but you can't specify what is the type inside of that array. You can have an object type, but you can't specify the shape of that object. So the foundation in Bicep is set to be able to have more specific types for those sorts of things and be able to do more validation and provide more IntelliSense. We just haven't had an opportunity to get to it yet, but we will definitely get there in the future.
One way I've used the arrays of objects is for Azure Service Bus, where if you've got topics and then each topic might have one or more subscriptions in, I've done like an array of objects where in each object there's a topic name, and inside that there's an array of subscriptions, and then I just need the one resource, or the resource for the topic, which is a for loop, and then it just works. It just means it's like the actual Bicep code is really succinct, and then I've got a big long array of objects which describe all the topics and subscriptions inside each topic, and it's just so clean. It's really nice.
And we actually have a new-ish feature that allows you to load a JSON file or any text file. And for JSON in particular, we can actually turn that into an object literal, which means we can do IntelliSense on that JSON object in Bicep. And for anything where you have an array of objects like that, that could be coming from an external source. It could be coming from all sorts of places, and you can just kind of feed it in and everything just works. And you get really clean separation of data and code, which is really nice. Any other questions? These are great questions. This is an awesome discussion, which I'm not surprised by.
I know I've asked you this before, but when is resources as parameters into modules due?
We were trying to get it done in 0.5. It's more likely going to be, so we're going to do 0.5 and then we're going to do 1.0 after that at some point. I think it'll end up being part of the 1.0 release, which I'm expecting to be like early 2022, like January 2022.
Well, yeah, because I think that's my only pain point at the moment, just having to, the scenario I described before where I've got to use existing for something that's in the same deployment. But once that is sorted, it's just, yeah.
Yeah, in hindsight, it's like, why didn't we do that right from the beginning? It's like I think it's just going to make the end-to-end experience so good because it's going to be so easy to pass these things around.
So what is the type going to be? So is it going to be a resource, or is it going to be a type for each different? Because obviously in Azure you've got different types of resources.
You'll be able to keep it generic, so you can do param my resource, and the type will be resource. If you don't know what it's going to be, or maybe the type will be dynamic, especially for what we sometimes call extension resource types. So that's things like resource locks or diagnostic settings that kind of hang on to a generic set of resource types. So that's when you would want to keep the type generic. But if you do know the type and you know it has to be a VNet, you'll be able to specify that as well. And then we can validate that the resource that's coming from the other module is in fact a VNet. It's not some generic resource type.
So does that mean that you've got to create a type for every single resource type in Azure?
It'll be, it's kind of, we don't have to actually publish. I mean, we do have types for every resource type in Azure based off of Swagger. But even if we don't know the type, we'll still allow you to express that type. So you'll be able to say resource and then the full resource type string. It'll be Microsoft.whatever/whatever, including the API version.
So it's going to be the same as what we've got against resource now.
Exactly.
In the parameter. Cool.
Yep. Same list. Do you get as rich output if there are errors using the compiler, or is the smarts for that just in the VS Code extension? Great question. The code base between the extension and the compiler is literally the same. So we package it up as a VS Code extension. We package it up as a native binary for the compiler. So if you see something happen in VS Code, you'll get the exact same results in the compiler. And that's one of those core tenets of language design that we never would have known to get right if we didn't get some really good advice from people who have done this several times before. And it's part of that foundation that makes the language so good to author and fail so gracefully and have a clean experience no matter how you're using Bicep.
I find a lot of time if we don't get linting errors and it the Bicep output doesn't tell me what was wrong, and I've got to quite often, I know this isn't a Bicep thing, this is an ARM thing, but I've got to go to, so if I'm deploying to a resource group, for example, I would go to the portal, the resource group, the deployment tab, and then that would give me the error JSON, which would tell me what's wrong. But quite often I don't see it in the output that often. Most of the time I've got to go to the portal.
If your output, like if you're deploying from the CLI and it fails there. Stephanie, do you want to talk about some of what's going on to improve the output in the CLI?
Yeah, so we've been working on trying to make it a little more readable and understandable. Something we've been working on for a little while now. We want to be able to create a table or some sort of output to be able to let you know when things are deploying, when they're failing, or when they've been created. I think I might have something I can share with you, but I'm not sure if it's something we do want to share right now. This is a design that's very rough that we're still trying to make better. So maybe Alex?
Yeah, I mean, generally, it's probably not, worth sharing the mock-up for the change, but we are going to have, the idea is to emit the exact same information in a readable form that you see in the portal into CLI. So I'm not, maybe the .NET CLI does this in some places, but front ends for CLI output have come a long way, and there's some really cool libraries for visualizing things in the CLI. So we're going to take advantage of that to give you kind of a richer real-time output of how your deployment is going.
That would be amazing because, as I said, 99% of the time, if it fails, I've got to go to the portal. So to have that view of all the different deployments that are happening as part of that one deployment in the output would be amazing.
Yeah, and for bonus points, I don't know if anybody's using the GitHub CLI, but I've started using it a lot. They have a really nice command, and I've seen this in a few other places where you can do like GitHub GH is the command, GH repo view, and then -- web. And there's enough context to take you to exactly the right spot in GitHub. we'll be able to offer something similar where you can go from your deployment in the CLI to that deployment in the portal if you do need to get richer information for whatever reason.
Yeah, and so the design is basically based off of what you can see in portal. So we're trying to make it as similar an experience as possible. So you don't have to go directly to the portal. And we're hoping to also print out a URL so you can click on it to go to portal instead of having to search for it yourself.
I was just going to say, if this is the first time you've seen Bicep and you want to go into a bit more depth or anything like that, and if you have more questions or anything of that nature, or you want to know how to adopt it in your organization, or if you have customers, if you're a consultant and you're working with customers and you want them to adopt Bicep and they want a deep dive, please don't hesitate to reach out to us. I'll put our emails in the chat so you guys have them, or you can always reach out to Dan, who can reach out to us. We're always happy to do those kinds of deep dives or anything that you need to be successful.
We're always trying to find ways to improve. So any criticisms, as long as they're constructive, would be nice. Any criticisms, let us know. We'll try to do our best to make it better.
And I'm going to put all the links you put in the chat answering questions. I'll put that onto the .NET Oxford web page as well when we publish the meetup notes.
Okay.
Cool. I think that's the end. I think this is possibly the most questions I've seen for a long time. So yeah, they've all been pretty good questions and an awesome presentation. And yeah, Bicep. I haven't used Bicep. I was the kind of that hand guy when you asked the question, but it looks awesome. So yeah, again, it's another thing that I can kind of put on my list that I need to pick up for ever growing list of things. But thank you so much, guys. I'm sure you and the team as well have worked very, very hard on this in the background. So great job. Looks really good. Thank you very much for joining us. So I guess just about still morning for you, maybe just verging into afternoon.
It's 12:05, so it's
12:05.
it's past noon.
Lunchtime.
Lunchtime. That's it. Yeah.
But for you guys, big
well, yeah, for most of us, it's evening time. I think, yeah, we get people from all over the place now. I think, one of the niceties I'm sure everyone can say is that we've had people from kind of all over the world over the last kind of couple of years. So that's been kind of quite nice in a way.
Well, I hope that we can do the next one in person. I think
that would be awesome. You definitely welcome.
Hang out for a while.
Yeah, man. Yeah, do it, definitely. So anyway, guys, thank you so much. Everyone else, thank you for taking time out in your evening as well, coming to spend the evening with us. Obviously, for those of you who've been here before, and for those of you who it's not like morning, we're gonna probably, like, a few of us stick around and have a few beers and have a bit of a chat as well. Feel free to join with or without beers, it's fine. Unless, of course, you've got a work day to get to, in which case, not so great. As Dan said, next month, October 5th, we've got talk about JetBrains Rider from Mateus, who's gonna kind of tell us a lot more than Dan did in his lightning talk about it, I think, a year or two back. So that should be awesome. Go and listen to Dan's podcast. Dan will pay me money for saying that, hopefully later. We'll see how that goes. But definitely worth a listen. It's pretty good. Some guy called Alex talking on one of them. He was quite interesting too. So it's all good. But yeah, please. That's it. So yeah, thank you guys. Please join us on the 5th of October to find out more about Rider. Yeah, stay online if you want to. If not, have a good evening or good afternoon or good morning or good whatever the heck it is, wherever you are. But yeah, thank you very much, guys. Cheers.
Thank you, guys.
Thank you so much for having us. I think Stephanie and I both need to drop, but we'll hang out at the next one for sure.
No, it's good to have you guys. Thank you for coming.
Thanks.
Yeah.
Bye, guys. Have a good night.
Cheers.
Bye.